Next question is asking on the percentage by mass of phosphorus. They are not asking for nitrogen, okay? But they give you a statement. The 30.0% P2O5 soluble in water, okay? So what is going on here? Let's see. So the MR of P2O5 is 31.0 times 2 plus 16.0 times 5 based on your A-level periodic table. We know that the fertilizer, okay, only 30% is P2O5, okay? So how much of that is actually phosphorus, okay? How much of the fertilizer is actually phosphorus? So we got to think about the percentage by mass of phosphorus. If you just go from here to here, we can easily see that there are 2 phosphorus in P2O5, so divided by the molar mass of the P2O5, but that is from here to here. But then we all know that only 30% of it is P2O5, so I need to multiply by 30 over 100 because only 30% of the whole thing is actually P2O5, okay? And then I need to convert the whole thing to percentage by multiplying by 100%, okay? It so happened that the 100 and the 100 can cancel out, so 2 times 31 divided by 142 times 30, I got 13.099, that is 13.1% to 3 significant figure. Okay, simply because the data that they give us is to 3 significant figure, and also the molar mass that you work out from the periodic table is to 3 significant figure. If you include the decimal place, it's 4 significant figure, but 3 to 4 significant figure in a theory paper is perfectly acceptable, dependent on what data you have been given. Alright, so the answer here is 13.1%. Okay, what's confusing really is interpreting this 30%. Okay, this is probably where most of you students will have missed out on here. Okay, or even the number of phosphorus in P2O5, there are 2 of them. Okay, so in this question, this is about a hydrocarbon combustion, C6H12. Instead of asking you on volume, they talk about increase in mass, okay? So mass ratio is not the same as volume ratio, yeah, okay? So this anhydrous calcium chloride absorb water. So how much water would you produce, okay? Water is liquid at room temperature and pressure. It wouldn't be a gas, all right? This absorbs CO2. So if I have C6H12, let's write a balance equation for the combustion of C6H12. That gives me CO2 plus H2O. I'll get 6 CO2 because I have 6 in the carbonate, 12 hydrogen, so I need 6 H2O. The oxygen, I have 12. The oxygen, I have 6. 12 plus 6 is 18. So to get 18, I need 9 of the O2. All right. They don't tell me how much I actually burn. Okay, they don't tell me how much I actually burn. If I just work out the MR, molecular mass, 12 times 6 plus 12, that is 84. Okay, I don't care about the oxygen because this is in excess. If you had a look there, excess of oxygen, you use excess anyway. And then the MR is for 1 mole, okay? That is the definition of molecular mass, the mass for 1 mole of the substance, yeah? CO2 is 12.0 plus 16.0 times 2, that is 44. Okay, the H2O is 18. So what can we say? We can say that if I burn 1 mole of this, okay, if I burn 1 mole of C6H12, I will get 6 mole of this and I'll get 6 mole of this, okay? So therefore, what is the increase in mass then? I will get 6 mole of it, which is, if I have mole is equal to mass over MR. So mass is going to be mole times MR. So 6 times 44 gram. So 6 times 18 gram. If burn 1 mole of C6H12, okay? So what can we say? In P, the P there is for the mass of H2O. The Q there is for the mass of CO2. So we're looking at mass of H2O over mass of CO2. MP over MQ is the mass of H2O over CO2. So the H2O is 6 times 18 gram, and then the bottom is 6 times 44. The 6 cancel out. So if I do the fractions correctly, I get 0.4091. That will round up to 0.409. Do they want 3 sig fig? No, they want 2 sig fig. The closest one is 0.41. Okay, so 0.409, the closest one is 0.41. Confusing thing there is really they're dealing with masses, but they didn't give you any mass of it. So you have to get a balanced equation and think about for 1 mole of it, how many mole, and you relate mole to mass. The 6 really does cancel out simply because of the balance equation. Alright, so it's not a bad question, it's a really good question actually. Moving on to the next question. So you heat 1 mole of this substance. Any gas produced is collected. So this is actually related a little bit to group 2 chemistry, which you will do much later in AS chemistry. However, you have done enough group 2 chemistry in your O-level to realize that you can definitely decompose MgCO3, and then you get MgO plus CO2. There's a gas, there's a solid, and there's a solid. Unfortunately, you might not know this one. So the group 2 nitrate decomposed to give you the group 2 oxide. Group 2 oxide meaning Mg2 plus O2 minus. And then with NO3 minus, you have 2 plus and you have a minus 1. LCM is called lowest common multiple. You did it in primary school. It's 2. So therefore, you will need 2 of it, so that the charge become minus 2 overall to balance out the 2 plus, okay? That's why the formula for magnesium nitrate is MgNO3 twice. It will give you NO2 gas, and give you O2 gas, and your equation will not be balanced. You got 1 oxygen, you got 4 oxygen, so 5 oxygen, you got 6 oxygen. You only need 1 more oxygen atoms, but you give off oxygen gas as a molecule, so it's always gonna give you a half there to balance the equation. So what can I tell you? If you have 1 mole of each of these substances, 1 mole and 1 mole, the magnesium chloride doesn't give you any gas, it doesn't decompose. The magnesium hydroxide doesn't decompose further as well. So you only want to collect 24 dm cube of gas. You only want 24 dm cube of gas, okay? Here, 1 mole of magnesium nitrate will give you 2.5 mole of gases, because I combined the 2 gas together. 2 plus 0.5 is 2.5 mole. Okay, we're talking about volume of gas at room temperature and pressure. Earlier, you have seen the molar volume of gas is 24 dm cube per mole. So it doesn't matter what gas you are, as long as you are gas, 1 mole of that gas will occupy the volume of 24 dm cube. So 1 mole of this gives you 1 mole of CO2 only, therefore only 24 dm cube of the gas based on molar volume definition, okay? Whereas here, if you get 2.5 mole of gas by decomposing exactly 1 mole of that, you're going to get 2.5 times 24 dm cube. You're going to get 48 plus 24, that's 72 dm cube of gas total. Okay, so that is not what you wanted in the question. You only want 24 dm cube of gas to be collected. All right, moving on to the next question. So in this question, it's a bit of reading. Number of atoms. So we're looking at the atoms, even though they give us, well, methane is a molecule, ozone is a molecule, carbon dioxide is a molecule. They tell you this is an atom. So we got to work out the number of atoms. So 1 gram of hydrogen, okay? So hydrogen gas is existing as H2. So the same number of atom as 1 gram of hydrogen. The number of hydrogen atom, okay, is to the hydrogen molecule. In 1 hydrogen molecule, there are 2 hydrogen atoms. Well, there are 2 hydrogen for 1 H2. 1 H2 has 2 hydrogen. Okay, so the number of H atom actually over the number of mole of the H2. So the mole of hydrogen atoms over the mole of hydrogen molecule, that is 1 gram over 2 gram. Okay, 1 gram over the mR, because this bottom bit is for the molecule, this top bit is for the atom. So the mole of hydrogen atom is equal to 2 times half over 1 is just 1 mole. So you're looking for 1 mole of atoms, because 1 mole of atom is all you have in 1 gram of hydrogen molecule. Okay, be careful, atom versus molecule. Now in CO2, you have 3 atoms per molecule. Well, you can see you have 1, 2, and 3. In CH4, you have 5 atoms. Okay, 5 atoms total. Here you have 3 atoms total. Here you have 1 atom because it's monoatomic. Here you have 3 atoms because it's O3. Okay, so what I'm going to do with CO2 is the mole of atoms over the mole of CO2. There are 3 atoms in 1 molecule of CO2. So the mole of the atom over, well, the mole of CO2 is the mass over the mR, so it's 22 over 44. So it's 22 over 44. Remember, the bottom bit is for the molecule, the CO2. So the mole of atom is equal to 3 times 22 over 44. That is not 1, okay? So I can cross out carbon dioxide. Okay, how about 8 gram of CH4? So the mole of atom, CH4. 1 CH4 has 5 atoms, 1 carbon and 4 hydrogen. What was the mass just now? 8 over 16. I can tell you straight away it's not going to give you 1, because you can tell 8 over 16 is a half times 5. I can work it out for you, but you should be able to see at this point that will give you 5 over 2, which is 2.5. It's not 1. So CH4 is not the correct one again. How about neon? Okay, so neon is monoatomic. So 20 gram of neon. Maybe I can do my working up here now. So 20 gram of neon. So the mole of atom over the mole of neon is just 1 over 1. So the mole of atom over 20 over 20, because that's the mass of the neon divided by the atomic mass. And the mole of the atom is 20 over 20, which is just 1 mole. And that is exactly what you want. Okay, so C is the correct answer. But if I quickly work out for D, so the mole of the atom over the mole of all 3 molecules is 3 atoms for 1 O3 molecule, and the mole of the atom over the mass over the mR, because the bottom one is the mole of O3. You can see the mole of atoms there is 3 times 8 over 48. I can tell you that is not 1 mole. Okay, that's definitely not 1 mole, because 8 times 3 is 24. 24 over 48 is 1 over 2. Okay, so not so bad there. It's a question about atoms versus molecules. Just gotta be careful, yeah, if you're reading. Next bit is about balancing equation, believe it or not. Okay, why is it confusing? Well, Mg3P2, so just reacting with water, you produce P2H4. You produce P2H4, 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 spontaneously flammable in air. Which one is balanced? Okay, the easiest thing is probably 3Mg, 3Mg. Okay, so the magnesium is balanced. 3Mg, 3Mg, the magnesium is balanced. 6Mg, 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 the magnesium are all balanced. There's no use at looking at magnesium. How about looking at the phosphorus? Okay, so the phosphorus here, there are 2 phosphorus. There are 2 phosphorus, so phosphorus are balanced. 2 phosphorus, 2 phosphorus, phosphorus are balanced. 4 phosphorus, 2 times 2. Here there is 2 phosphorus, 2 phosphorus, so 2 plus 2 is 4. 4 phosphorus. There are 6 phosphorus here. 3 times 2, 6. 2 times 2 is 4. So D is out already. So I already checked for phosphorus. Okay, next up I should check for hydrogen. Okay, 6 times 2 is 12. Here I have H2, so there's 6 hydrogen. 6 plus 4 is 10 hydrogen. Okay, so 10H on the right hand side. So 3 times 2, there's 6 hydrogen, plus 4 is 10. 6 times 2 is 12. Okay, so that hydrogen is not balanced. There's no need to check the oxygen. Now here, there are 12 hydrogen. But remember just now we said this is the same as that, except that you have plus another 2 hydrogen atom. So here the hydrogen atom does balance out. There is 12 hydrogen altogether on the right side. Okay, this is the same as that, except there's 2 extra hydrogen there. How about this one? There are 24 hydrogen, 12 times 2. So there are 6 times 2, there are 12 hydrogen. 12 plus 4 is 16. Okay, so 12 plus 4 is 16. 2 times 3 is 6. So 16 plus 6 is 22. So 22 hydrogen on the right hand side. We talk about 24 hydrogen on the left hand side. So the hydrogen are not balanced. Okay, so the hydrogen are not balanced for C, so it's not balanced. So only B is the correct answer. Okay, so we reached the end of this short tutorial. If you like what I have done with this channel and these new ideas of going through different multiple choice questions in a shorter manner, do subscribe to the channel to find out more in the future. Like the video if it's helpful, and then yeah, share with your friends, your students and your relatives. I've also started my other social media following as well, so if ever you want to drop comments or whatever, you can check those social media icons as well. Okay, thank you for watching. See you in the next video.